Greetings to all. This is Vaishnavi, Assistant Professor at IT Department from SNS College of Technology. Now we are going to see about the Docker and its components in cloud computing and its applications. Docker, it is a software deployment at a scale. It creates a portable application packages and it works in any environment, and then it improves the workflow efficiency. The benefits of the Docker will be easy packaging. It combines the application and OS dependencies, and it is an hardware independent. Next one, we have a problem statement. The software company develops an application that works perfectly on the developer system, but when it is deployed on the other machines, it's failed due to the differences in operating systems, libraries, and dependencies. It causes the delays, errors, so they need a solution to ensure the application run consistently. The solution will be the Docker containers. Here we have the 5 stages. First one is an empathize stage. In empathize stage, we have a developer frustration, environment differences, and the deployment failures. Second stage will be the define stage. In define stage, we found that the dependency conflicts, inconsistent environments, and then application probability issues. Third one will be the ideate state. In ideate state, we find the Docker container, Docker images, and then environment standardization usage as a solution. So fourth one will be the prototype. In prototype, we create the Docker file. Here we build an image and then run the containers across the systems. Fifth stage will be the testing stage. In testing stage, we have the crash platform execution and then consistency deployment. Next one will be the process simplification. The Docker simplifies both the workflow and the communication between the teams, and then it improves the overall deployment processes, and it reduces the complexity in managing applications across the environments. Next, we have the traditional deployment workflow. Here we use without the Docker. So it developer requests the resources from operations team, and then resources are provided and then given to the developers, and then developers write the deployment scripts, then continuous back and forth between the teams, and then dependencies are discovered and then installed repeatedly, and then process loops multiple times before the deployment, and then finally the application is deployed. Here we have the diagram for the traditional deployment model. Here we divided into two, that is development team and then operation team. In development team, initially it start from the request resources and then script the deployment, and then deployment is developed and then discover the dependency, and finally the application is deployed to the customers. Next one will be the Docker deployment workflow. Here we use the Docker. So developers build the Docker image, and then the image is pushed to the registry, and then operation team provides a configuration, followed by application is deployed quickly, and then it reduces the repeated step and the manual effort. So it ensures the consistency across the environments. Here we have the deployment steps. First one is build the Docker image. Here we have the create a portable application packages, and then second step will be trigger a deployment. Here it initiate the application launch, and then it provide the configuration. Here it will set up the application settings, and finally it is shipped to the registry, that is the store the image in the central locations. Next one will be the broad support and adaptation. It is supported by the major cloud platforms. It is here. It is used in that AWS, Google, and IBM. It is a strong industry packing, and then it works across the multiple cloud providers. It supports the multiple OS. Next, we have the Docker architecture. In Docker architecture, we have the client, and then server, and then Docker host, and finally Docker registry. It is a client server model, but it is a single executable. Here it uses the kernel features such as IP tables, C groups, and the namespaces. It is efficient resource usages. Next one, architecture components. Here we have a client as an send commands. In the server will be Docker, host OS, container, and image. In registry, it has that stores the images. Next one will be the Kubernetes architecture. Here we have node master, and then user interface control panel. Next, we have the assessment question. If we are the developer trapped in the dependency where every application breaks due to the missing libraries and incompatible environments, the magical tool lets you package your application with everything it needs and run in anywhere without the issue. So what is the tool? The tool will be the Docker. Thank you.